Good morning, good afternoon, good evening, wherever you are. I'm Gary Gandry and I'm here today to give you a revision session on part 2 of BS 7671 to Amendment 4 issued in 2026. When you start this revision session, you'll be pleased to know that there's only 2 questions in the exam. As you can see here, part 2 has many pages, but the bottom line is they're only going to ask you a couple of questions on it. It's worth 3% of the marks. Now, strangely, they sometimes give you the answer, but you've got to go and find the sort of questions. So sometimes they map them in a different way. So you need to read the question, and it will say da-di-da-di-da is defined as, is considered as. You know, you need to be very careful on the wording, all right, and be helpful. It might say defined as, is considered to be. You know, there's lots of little ways that the exam boards ask the questions, but you're only going to get 2 questions of this. Now, as I said to you last time, they should follow in order. All right, so the first 4 questions in the exam are based on part 1, next 2 are part 2, and the next 6 are in part 3. So quite quickly on, you could get that. But I do also know that sometimes, especially in special locations, sometimes it talks about PV strings and stuff like that, so it may come back, but there you go. Right, okay. Now, as I said to you before, you're allowed to use flag tags, you're allowed to use post-it notes, and you're also allowed to sort of make little comments in the margins and the like. One of your best friends is page 3 in the book, which is the contents list. If you haven't started to mark it up or use a ruler to draw across, then that might be helpful for you to do. Lots of people on these courses go, yeah, this is great advice, I'll do it tomorrow, I'm doing it later, I'm doing it the weekend, and then literally when we're face to face in the classroom, I come around and have a look at you and no one's done it right. I can't give you enough tips and tricks to help you get through this book. Our job is to help you understand the regulations, but there are tidbits of information that definitely can help you be more successful. Your friend is practice and familiarity. Your enemy is time. You've got 2 hours to do 60 questions, and on average it's 2 minutes a question, which is fine, right? But without you knowing it, and if you've not timed yourself, if you get a really awkward question, you put the timer on, you can be sort of 6, 7, 8, 9 minutes or so, and then get a really easy question afterwards, but that could be when the time's run out. In the online course, you have 65 different types of practice questions. Now, they should be random, okay? But the more you do, the more you practice, the more it'll come up and hopefully get through it. Don't worry about time, it's about being exposed to the type of question and then going off and finding it. So in part 2, there are 65 sample questions that in theory you should be able to sort of pick up. They are generated randomly, so if it comes to the point where you have thought, I've seen that question before, that's the unfortunate thing of it being random, but try and do it again or even bypass that one. Just keep hitting that sort of next button and seeing the question, so you are in a position to sort of look at it and think, I've seen that one before, I know where the answer is. Right, inside your books, please go to part 2 definitions. This is on page 32. I don't know if you can see here, but basically I've got my little box down here. Sometimes I use this as a sort of guide on the page because people say to me, where are we? So I do move this around. Now, previously we used to say this was the definitions, but actually part 2 covers terms and definitions. There's a bit of a subtlety there. All right, and the other thing that it covers is symbols and abbreviations. Now, most people find this tedious, but I can tell you now that there's an awful lot of vital information in this part of the book. So if you see something that I've highlighted, you know, don't be frightened of doing it, it's quite helpful. Now, we're not going to be in a position today because we've got no communication for cameras or microphones there, but I'm going to say to you that ambient temperature is considered to be the temperature of the air, but it could be of another medium, which could be soil. So you need to be thinking about buried cables, cables on walls, cables in boiler rooms and things like that. And what will happen is that you may need to refer to some tables that are in Appendix 4. So basically, I think it's 4B1 and 4B2 there for cables and the temperatures. So we will look at that in part 4, and we'll also look at that in Appendix 4 as well. Arm's reach. Now arm's reach is about arms out here, above, standing from the floor, you know, and basically leaning down and putting your arm into a pit zone. So if you haven't got anything there, what you need to do is look over here, and can you see figure 417? So in part 4, section 417, there's a figure. All right, I suggest that when you find that, you actually write down the page number and put it on there, because it's quite a nice thing to do, and you'll be asked some questions there. It's normally 2.5 when you're on the floor, 2.5 up, at 1.5 out, 1.25, sorry. All right, so looking at that one. Coming back to the page, they're all in alphabetical order, so basically you should be able to find these in a nice way. The other thing I normally do is barrier. Okay, so these are the things you want to sort of be familiar with, and they're all discussed in the training material, so if you're not familiar with this, please come back to it. A barrier is not the thing walking down the road that stops you falling down the hole in the pavement, right? We use it as a special bit of protection between live parts, and basically it gives you protection from any usual direction, and that's the sort of clue you need to be looking at, right? Not all directions, the usual. Okay, so basically, as an example, do you know when you take off the front cover of a distribution board, there might be a barrier between that and the buzz bar. You know, that's that terminology then. Going down to basic protection, this is your insulation, barriers or enclosures, and the other bits and pieces. So this is protection against electric shock under fault-free conditions. Don't worry about the wording, all you need to be is familiar with it. So basically when you come to reading the question, it might say what protection would be used to protect against electric shock under fault-free conditions. Basic protection, fault protection, whatever, right? So you need to map it back. There's a whole new section on batteries. Okay, another one that I really do like to labour really is CPC. Okay, most people call it an earth wire, but it isn't. It's a protective conductor. It's one of the four protective conductors. One of the four protective conductors that you need to be familiar with. So you've got earthing conductor, you've got CPC, circuit protective conductor, you've got main protective bonding conductor, and then you've got supplementary protective bonding conductor. So you need to be familiar with those, and I'm going to show you a picture before we finish this session here. Right, sometimes it will ask you a question is, what does the CPC connect to? And I'll show you a picture of that one, CPC. So sometimes through training, through not understanding something, what is a CPC? If you'd have called it an earth wire, I would have understood it, but in the world that we live in today, we're trying very hard to push these terms. So it's a circuit protective conductor. The other thing I want to bring to your attention is class 1 equipment. This is generally equipment that needs to rely on an earth connection to earth for protection. Class 2 equipment does not rely on a connection to earth. The words sound very similar, so basically familiarise yourself with that. And class 3 equipment is equipment in which protection against electric shock relies on the supply at SELV, S-E-L-V. And in the past we used to call that safety electrical extra low voltage, and now it's called, oh no, we used to call it separated extra low voltage, now it's called safety extra low voltage, just to align with the standards. Distribution circuit. Okay, there's two types of circuit. There's a distribution circuit and there's a final circuit. Now again, I don't want to teach you to suck eggs here, but there's the difference, right? And the question will be something along the lines is, you've got a cable that connects distribution board A to distribution board B. Don't say distribution board, it'll say something like switchgear. So, and then it'll say, what type of circuit is this? Is it a final circuit? Is it a distribution circuit? So you need to map out in your head, you know what you're referring to. I haven't picked up on these things in, but can you see in the next two down here? DNO and DSO. Right, DNO stands for Distribution Network Operator. This is the entity that looks after the cables in the ground, up and to including the cutout of the building. And the DSO is also linked to that term. They're saying that the DNO will transition into a DSO, but I've got a contact in the electricity board industry. That's where I did my apprenticeship, and he stayed there, and he's authorised up to 132,000 kV. So basically, he knows what he's doing. He says, yes, we've got one of those. So what I understand is the DNO looks after the cables and the network and that, and the DSO says how much energy do you need today, tomorrow, next week. So as an analogy, it's a bit like your mum giving you pocket money and your dad telling you where you can spend it. Sometimes you'll see the word distributor also referred to, and that's similar to the cable. Now the distributor is a different entity to the supplier. So your supplier is the person, well, not the person, the entity that gives you the gas or the electricity, or where you buy your gas or electricity from. So I live in the south of this country, so I live in Kent, but I could be buying my electricity from Scottish Power, for example. If you've got anything about EV, about charging modes, you come here strangely. Right, talk to you about these two things. One's an exposed conductive part and the other one's an extraneous conductive part. For some strange reason, people find these very difficult to sort of manage there. An exposed conductive part is something that would have LNN, so live parts inside it. So basically there'll be like an enclosure here, it'll be inside it, so it'll be like a distribution board, conduit, metal conduit, steel conduit, trunking, or a wash machine with a metal case, you know, anything like that. So you basically got live parts inside a metallic case. And an exposed conductive part, as you can see, is a conductive part of equipment which can be touched and which is not normally live, but which can become live under fault conditions. Okay. Now, sneakily, they will ask a question, and it might be A is a conductive part of equipment which can be touched and which is normally live. And they've missed out the word not, and you've gone, that's the one, A, move on, right? But basically, if you'd have read the rest, and option D in the question would be the same thing, but they would have put the word not in. It's a trick question, but I want you just to be aware of it. So look, which is not normally live. So they put the answer in, but they would have left the word not out. But in option C or D, it will appear with the full. So do take your time to read these. Right, extraneous conductive parts is a conductive part liable to introduce potential, generally earth potential, and not forming part of the electrical installation. Okay, so this is a metallic part that comes generally out of the ground. It could be a cast iron soil pipe, could be a gas pipe, could be a water pipe, you know, like a lead pipe or something like that. And basically, you could be 10 floors up there, right? Something becomes live, and you touch this metal object. There's steel stanchion, for example, that can go all the way into the ground, and you'd get electric shock. So that's the difference. It has no live parts inside it, so you need to sort of map out that in your head. Fault current is a current resulting from a fault, and the other one I wanted to bring to your attention is fault protection. All right, now this is protection against electric shock under single fault conditions. So we've got these two here. All right, so basically when basic insulation has failed, either through damage, wear and tear, old age or something like that, the live part could be come in contact with an earthy part. That's fault protection. I've highlighted final circuit there. That's a different type of circuit. It's the one that, I mean, I don't know if you call these at your place, but you probably don't have them as ring mains. But you know, a ring main is connecting between 11 kV transformers, and they connect up like around factories and universities and hospitals. In a domestic dwelling, it'll be a ring final circuit because it's the last part of it. There's lots and lots and lots of other ones on here. The sort of ones you want to be familiar with is fuse carrier, fuse element. They might ask you a question, which bit blows in the event of a fault, just to see whether you can read that. Here's the one that comes up quite a lot for prosumer installations. You've got island mode. So it's PEI stands for prosumer's electrical installation. I've kept this in here, but when we were working on the regs, because things got changed at the last minute here, and when we were doing the final proofing, we decided we really wanted to get away with the word isolator. All right, there isn't a thing called an isolator. It's a switch disconnector, switch, and this is all about turning off on load or off load. Okay, so you can use the word which device are you using for isolation, but the term isolator should be removed from the book altogether. So it's something colloquial, a bit like the earth wire thing with the CPC. So you say, oh, where's the isolator? Right, it should be, where's the switch disconnector? So it's just got to get used to the new terminology. Right, live part. It's a conductor or a conductive part intended to be energised in normal use, and it includes the neutral. I will stress this as we're going through the course. L and N are both live conductors, but by convention, not a pen conductor. You want to be familiar with what the main earthing terminal is? And like EVs, there's a bit on medical location, so you might need to find out what group 1 and 2 is and all that, etc. I'll touch on obstacle in a minute because I've got a picture to show you. Right, overcurrent. I'll touch on this in part 4 as well. Right, this is a current that exceeds the rated value. For conductors, the rated value is the current carrying capacity, right? Overcurrent is different to overload current. Okay, so sometimes, well, in fact, let's do this. Overcurrent is an umbrella term. Overcurrent is the umbrella term for overload and fault currents, and there's two types of fault currents. There's earth fault and short circuit, so you need to be familiar with that. So when it comes down to an overload, there's actually nothing wrong with the circuit. It is an electrically sound circuit. What you've done is abused it by one. For example, if you go home now today and plug in the washing machine, the kettle, the tumble dryer, the microwave oven, the toaster, you know, whatever it is, and just keep putting it, right, you've overloaded the circuit. There was nothing wrong with the circuit, you've just abused the circuit. It's the same with a motor. So when you're working on your production lines, if you've got conveyor belts and you know you keep putting boxes on it and more loads, it's going to put extra stress on the motor. So again, you've overloaded that particular type of circuit, or something gets jammed maybe. There was nothing wrong with the circuit, it's an overload. Prosumer's electrical installations will come up a lot in part 8, and the sort of things that you need to be familiar with is PEI collective, PEI individual, and PEI shared. So PEI stands for prosumer's electrical installations, and we'll cover that later in the course. I hope you know what an RCD is. There's another one that comes up in PEI, reverse feeding mode. So basically, I said to you, there's island mode, reverse feeding mode, and I think there's a direct feeding mode, but I'll have to come back to that one. There's also ring final circuit. I'm going to test you on this in a minute. Selectivity. There's all the different types of system you can get. I do want to talk to you about this one here, verification, right? This is all measures by which all measures by means of which compliance of the electrical installation with the relevant requirements of 7671 are checked, and it comprises inspection, testing and certification. So you may be asked, what does verification cover? This and that, bits and bobs, you know, or these three things together. You can have a look at the list for voltage nominal. They cover extra low voltage and high voltage, voltage bands. And this is what I want to tell you. This picture here used to be very small. I managed to convince the IET to make this as big as possible, but the thing is there's only a certain amount of space on the page, so it was looking good with the image, but this text here was so small, right, most people couldn't read it. So do focus on this and make some little comments. I'd like to pinpoint in B. B is the main earthing terminal. Okay, so if you look at B down here, you'll see that it says main earthing terminal. Right, anything that's got M on it is a class 1 bit of equipment, and the number 1 should be CPC, which it is. And over here we've got a steel stanchion pipe. Sorry, steel stanchion. And this is a pipe coming out of the ground. So look, number 2. So there's different types of conductors here, and they are main protective bonding conductors. And the ones with the dotted lines are supplementary protective equipotential bonding conductors. The one that catches everyone out is number 3, so I want you to pay attention to that. This is the bit this is the conductor that connects the main earthing terminal to the means of earthing, and you can see down here that it's just 2 words, and it's called an earthing conductor. Right, just before I go into symbols, I want to come back to this particular variant. You will become tired of this. There are 4 protective measures in 7671, and they're called ADS, automatic disconnection and supply, and that's covered in part 4, section 411. I don't know if you can see my mouse, it's up here. Then it's double or reinforced insulation, which is 412. Then there's electrical separation, which is 413, and we'll go through these when we get to part 4. And there's also ELV self-propel, which is 414. And as I mentioned in the part one, sometimes you need basic protection and fault protection on their own. So you can't just have insulation. You need insulation and barriers and closures, and you also need fault protection. So you need fuses, circuit breakers, RCDs or something like that. You put the 2 together, and then you get the protective measure. So be familiar with that one. Basic insulation is brown and blue, and as we just discussed, both conductors are live conductors. The little copper bit in the middle is not the earth wire, it's the CPC, which stands for circuit protective conductor. But you could have barriers, right? So basically you can open the front cover and there will be a live part there, but there's a little, for the want of a better phrase, a shield, right? Or you can have an enclosure, and can you see those arrows? That gives you protection from any and all directions, all right? So from the top, from the front, from the sides and the bottom. Whereas the barriers is just from the normal use. If you go for an obstacle, right, you can have a particular type of object, not chairs, not boxes, okay, but there'll be live parts on the wall. You would not design an installation today like this. This would be in an old switch room or a transformer room or something that I'm just going to show you, but you can't just walk up to it. You should have some sort of, I'm trying to find another word. It's called an obstacle right now. You can have you can climb over it, you can climb through it, you can even lift it out. It doesn't have to be bolted down to the ground, but it's to prevent unintentional contact with the live part. So if you were walking back in the room and you bashed into it, it would hopefully prevent you there. And the minimum distance is 1.25. Now to get the point across, I've got to go way back to my apprenticeship in the early 1980s to see stuff like this, and I understand that there's still some in some switch stations now. All right, they didn't think it was a problem because you could see it, you could smell it, you know, it was really crystal clear. But you know, if you drop any metallic parts between the two, it's going to get a massive flash. So it's not particularly safe. But there you go. That's what we used to deal with. You can also do something called placing out of reach. Now, it's not. Some people think that's like leaving the front cover off a switchboard a few meters up the wall. That's not what it's there for. If you look at this particular picture, you'll see that over here, this is a crane. They call it a down shock crane conductor. So basically, it's picking up very heavy loads, but it gets its supply from these rails right here, and they're open. They're bare, right? So basically, you've got 3 phases there. And it could be a terrible situation if a scaffold pole or a metallic ladder or something like that basically shorted them out. In fact, I know a tragic story where a father and son were working in there. They didn't know about this, and he said, "Dad, you're getting older." He said, I'll go up and clean the high bay lighting." Stood on this, climbed across that, reached up to this, put his hand on that one, and killed him straight away. So be aware of that. You'll be pleased to know that modern manufacturing methods these days don't tend to, they use a different pickup mechanism. But back in those days, that's all they were allowed. That's all they had to do. Right, moving on. When you've got a protective device that's in series with another protective device that's in series with another protective device, which is shown by the red circle there, if you end up with a fault or an overload, which device do you want to blow? 3-1, 2-1 or 1-1, right? And most people say to me, it's this one, because if you take out that one, you lose everything. Now, we used to use the word discrimination, right? But that seemed to be discriminative. So now we use the word selectivity. And it's defined, right? So you might still call it discrimination, but the proper word is selectivity, and that's where we're going to be moving forward, and it'll stay that way. Now, you can have partial selectivity or total. So if you go for that one, it's your choice. Sometimes you don't mind that one going, but in your world, that wouldn't probably be a good idea, because that'd take out maybe a whole production line. So that's a new terminology change that you may not be familiar with. I also want to take you back to the back of the book, which is Appendix 15, and there's a nice picture there on ring final circuits. Okay, and as you can see, there's some boxes there. Don't be frightened of reading those boxes, because it's got vital information, and I would suggest that you read all of this information here, because there's a couple of little questions that come up that are very helpful, and the information is hidden away. Like, you can have a 30 amp or a 32 amp device there. Now, from your point of view, I understand that not everybody in factories uses ring final circuits anymore, because they're using radials or armoured cables, but they're still familiar and common practice in domestic dwellings. So just be comfortable with that one. There's also this question, right, which is, you'll see a picture similar to this, which one is the spur? Right, so I'm going to reach out to you now, guys. Right, so in the chat, is it A, B or C? Well, both of you have gone for B, and I'd like to say to you, you're both right, which is very good. So it's actually the cable, not the socket outlet, which most people do. So thanks for that. Well done. Right, now we're on to the questions. I'm going to have to ask you again. Sorry, so quick question in there. Right, so basically we've got protection against electric shock under fault-free conditions can be achieved by the use of fault protection, basic insulation, main bonding or backup protection. the answer is B, basic insulation, which I think you both got right, so well done to you. Right, okay. Right, up in the ante here, we've got a 24 volt fire alarm circuit, and it's classified in BS 7671 as a band 0 circuit, a band 1 circuit, a band 2 circuit, or a band 3 circuit. You're cooking on gas today, gentlemen, because the answer is B, band 1. Now you'll get that answer here because if I come back to part 2, right at the back there, we've got the voltage nominal, yeah, and then we've got the voltage band here. All right, and band 1, yeah, is normally it falls in with the extra low voltage side of things, so anything under 50 volts for DC, so it's good stuff, well done. Right, here's a trick question. When it comes to AC, low voltage between conductors and earth is defined in 7671 as a value not exceeding what value there? So question 3 for AC. So the question's over to you, gentlemen. Right, so I've got one answer is B, right, BCB. Right, well, I'm going to surprise you now. The answer is A, which is 600 volts AC, and the reason for that is because of this. Right, extra low voltage here is not exceeding 50 volts AC or 120 volts ripple free DC, whether between conductors or to earth. The bit that you need to be familiar with, and I think this is where it comes on, is everybody's rammed home about this, is that 7671 covers voltages right up to 1000 volts AC and 1500 volts DC. But what is not fully appreciated is the text that's here. So low voltage exceeds extra low voltage, but not exceeding 1000 volts AC or 1500 volts DC between conductors. So that's live conductors, L and N, L1 and L2, L1 and L3, etc., right? And then can you see this? Or it's 600 volts AC or 900 volts DC between conductors and earth. So can you see that if you've got two conductors, you've got two layers of insulation to protect you from shorting out here, but sometimes when you've got one layer of insulation to earth, the voltage is going to be a little bit less, and that's the reason why it comes in there. So if you understand that, you would have gained a mark. If you didn't appreciate that, you just thrown an easy mark away. Anyway, not to sort of beat you up on that one. Oh, I showed it on here as well, right? Okay, so basically there it is. So if you haven't found it, it's on page 50. And there it drills into the detail. So it's about the conductors and to earth. Part 2 also has symbols. which you will get a lot in the exam. So there will be some rating factors. There'll be C min, C max. So C min, right, is referenced in, so this is the 0.95 factor to correct ZS values. So again, you might want to make some little notes there. IB is the design current, and we'll cover that in part 4. IN is the rated current or the current setting of the protective device. There's a very nice formula that's coming up, which is not always easy to remember, but when we get to that, I'll give you the tips and tricks on that one. And the other one that comes up a lot is IZ, which is the current carrying capacity of a cable. So I'm sure you're familiar with that formula. Now, one thing I do want to bring to your attention is here, is that sometimes you might want to look for the symbols in the book. Now you'll be going, oh, I know where symbols are, they're in part 2. But if you take the tab of your book and flick to part 2, you got to go through all the A's, all the B's, all the C's, all the D's, etc., right? But I'm sure you know by now that symbols and abbreviations is at the back end of part 2. So the best thing to do really is open up part 3 and just turn back a page or 2, save you a bit of time. Same with looking for anything that's defined as S or T or V or W, right? Zones, Z for zones is, you know, it's easy to go to part 2 and flick through, but, you know, try and make this work for you. Every second, every 10-30 seconds that you can save will be a bonus that you can use on a more difficult question. And as I said to you last time, that when it comes to reading the question, if there's a lot of words in the question and a lot of words and symbols in the answers, just leave it, right? Come back to it, right? You don't even have to flag it because it'll be highlighted, not answered, all right? Those things just tease you, they're all distractions. So find an easy win, get some points, and then come back to it. You can do that sort of rotation part of things for as many times as you like for the 2 hours of the exam. And finally, for part 2, you've got the abbreviated terms. It's interesting that people want various words and terms in there, but some are supposedly easier to remember than others, but so they're only handpicked, there's nothing special about them. But if you want to know what a DNO is, you know, distribution network operator, DSO, etc. EBB stands for equipotential bonding busbar. EEMS is an electrical energy management system. ELV is extra low voltage. You know, it's ENA, Energy Networks Association. The other one that I've seen come up and causes people problems is ESQCR. People say, oh, I didn't even know what that is, or was. It's the Electricity Safety, Quality and Continuity Regulations. They are the regulations that look after or dictate how the electricity cables are put in place outside, you know, not in the installation, the bits and pieces that get to your installation. So it could be overhead or underground. HMO, right? Some people have never heard of that before. That's a house in multiple occupations. So that's, you know, you've got lots of people living there and the like. IEC is International Electrotechnical Commission. I work on this. I do a lot of international committee work. So basically, the IEC standards, which is IEC 60364, cover everything that we do, but just at a high level for everybody around the world. And what we do is we take it in at CENELEC for harmonised documents. That's where the ENs come from, and then it's filtered down to our national standard, which I serve on BS7, JPEL 64, which looks after BS7671. Now, just as a reminder, some people still don't quite get it. The BS7671 is the, I was going to say the brown book, it's the orange book, right? Look on the front cover, the top right hand corner, there's the British standard number. Okay. Right, that is the end of this session. I hope you found it useful. I'll have a quick look in the comments to see if you've got any questions, but that should be enough for you to get on with, and I look forward to you in a few weeks' time to do part 3. Take care and look after yourself.